Did, but it didn't.
Now we're recording.
Should I put this on my schedule?
Yes. Okay, so, I mean, you can put it right after. It all kind of flows. It's separate though. There is an assignment up for sketching polynomials, should be a quick one. I think it's, I don't know, like 10, 12 problems, something. I don't remember exactly. Should be pretty quick though. This is one where you're not really doing, there's only maybe one problem on there where you have to do any algebra. The rest of it is just interpreting the graphs, just the stuff you talked about, right? And we can look at some examples of that, like on tomorrow, maybe we'll pull up a couple when you've had a chance to look at them. I'll pull up a couple sample problems and we'll just zip through those real quick and start class. Okay, but I think you'll be fine. All the videos are up, all the notes are up from last time we talked. So, rational expressions. This is a logical extension of the stuff we've talked about. A rational expression is defined this way. Like R of x, we'll say, is a rational expression if it can be written in the form P of x divided by Q of x, where those are polynomials. So a rational expression is very simply a ratio of polynomials. That's it. Okay? We're gonna look at, kind of take the same approach we did with polynomials. We're gonna look at the algebra of dealing with rational expressions first, and then at the end we'll kind of take a look at what their graphs look like. But what the graphs look like is strongly related to the polynomial graph stuff we talked about. Okay? All right. So for today, we just want to, the topic for the day is we want to be able to, by the end of the day, we want to be able to multiply and divide rational expressions. And it's not hard to do. It's going to be, this is very quick. So let's first of all, let's think about how we would simplify rational expressions. Okay, so let's start with numbers. You could have all told me that 28 over 21 reduces to 4/3, right? Okay. Why does it reduce to 4/3?
You take 7 out of
Okay, because I can cancel common factors, right? Everybody agree? So if I were to, let's go ahead and write the numerator and the denominator in factored form, fully factored form. Now, we wouldn't necessarily have to do this with numbers because we can recognize maybe bigger factors that are common factors that we can cancel. But we're going to, the very next step is, we're going to remind ourselves how this works with numbers, and then we're going to jump into rational expressions that are algebraic, that involve variables, right? So to kind of set ourselves up for that, we want to write the top and the bottom in fully factored form. So if I were to completely factor 28, what do I get? What's it, factor tree? What's it?
1.
Well, we don't care about the 1.
2, 14,
2 and 14, which means 2 and 7. So I'm going to get a 2 squared
No.
times a 7, right, on the top? What about the bottom? 21, we don't even need a factor tree. What's that?
7.
Okay. And so do we have any common factors? Yeah, we do. The 7s would cancel, right? And we just end up with 2 squared over 3, which is 4 over 3. Okay? No big deal. I mean, that's, review from a long time ago. Okay, how does that apply here? If we want to simplify this rational expression, we have to do the same kind of thing, right? So what is this going, if I fully factor the top and the bottom, what am I going to get?
1.
So on the top, it's already factored. It's just a monomial factor, right? Top, all we've got is an x plus 4. What about the bottom? What's that factor into?
X plus 4.
Okay, so that is, this is, if we think of magic numbers here, the magic numbers that multiply to 16 and add to 8 are 4 and 4, right?
Right.
So that's the same thing as saying x plus 4 times x plus 4, right? We just write it as x plus 4 quantity squared, okay? So now that's our unsimplified factored version of our rational function. So the first thing we always want to do is write top and the bottom in factored form. What do you think we're going to do next? Okay, we're going to cross out common factors. But there's one important step that you have to do. In this case, it doesn't matter, but it will in some future examples. We always have to look at this, and we have to say, okay, this is true. If I simplify this,
I could cancel out one of the x minus 4s, right? And I end up with 1 over, or the x plus 4s. But I have to ask myself, are there any values of x that I would have to exclude? Because now think about our basic rules for real numbers that we talked about at the start of the year. There's really just two fundamental rules, two no-nos for real numbers. I can't take a square root of a negative number, or any even root of a negative number. So as we move into, the section after this one, the next unit, we'll look at like fourth roots and sixth roots and things like that. No even root of a negative number. So that's one rule. The other one was we can't divide by 0. Well, we're not dealing with any radicals here, but we have variables on the bottom of our rational expressions, and so we have to always be aware, are there any values of x that could cause the denominator to be 0? In other words, are there zeros of the denominator? Well, what's the only 0 of the denominator here? Negative 4. So this is our answer, but we have to include that one restriction to our domain, right? Because it's true that this is the answer, but this is only the answer if we also consider the fact that x cannot equal negative 4, okay? It becomes more important with an example like this. Okay, so what does this factor into? On the top. Okay, it's going to be, I can factor out an x, so I get x times what? Okay, on the bottom, what am I going to get?
X times X minus.
Okay, algebraically, is there any cancellation there, any common factors? The x's cancel, right? So those guys cancel, and so our simplified answer is just going to be x plus 1 divided by x minus 9. Are there any values of x that need to be excluded? So x cannot equal 9. Is that good?
No.
Seems to make sense. Are there any other values of x you think I might have to exclude? What is it?
Negative 1.
Negative 1's okay. The top, we can get 0 on the top. What's 0 divided by a number?
0.
0. That's okay. That's fine, because 0 is a number. But I can't have 0 on the bottom.
0?
What about 0? How come?
X over X.
Yeah, because look, I had this x over x there. Now, I canceled it algebraically, right? But it still was there in my original function, wasn't it? And what's the function that we're simplifying? That one, right? So any value of x that should have been excluded from the original function has to stay excluded from our final function, right? So we also have to exclude 0 because it was originally a factor. It got canceled, but that was just there to simplify it, right? The only reason it got canceled was because we wanted to write our answer in a simpler form, okay? I'm going to show you an example. Let's do a really simple one here. How about... Let's do this. So what if I take the function, really simple function. Let's do f of x equals x over x squared. Actually, let's do x squared over x. Okay, what does that simplify to? X. Okay, so I'm going to graph these on Desmos. Let's say that the function, I'm going to compare that to the function g of x equals x. Okay, we'll see if they're exactly the same.
No, they're not going to be. When X doesn't equal X.
You like that? Okay, so here's g of x. There's g of x equals x. Looks pretty simple, right? I can plug in lots of values there. I can go down and I can ask in Desmos, I can say, what's g of 4? 4. What's g of 2? 2. What's g of 0? 0. Okay?
G of 9.
G of 9. What is it? You tell me. 9. There you go. Okay.
Okay? And while we're at it, I'm going to be really tricky. Let's do this. Let's go. Oh, I know what I'm going to do. Okay, let's do this. Let's do the point. Oh, this is just so much fun to play with this. Okay. Okay, so let's do this. We're just going to put a point on here. So look what we did here. Look what we did. So I defined g of x as x. If I just drag in different values of a, let's make them simple ones though. Let's just make them like, let's just go negative 6 to 6 by 1s. Okay? So as I just drag in different values, it's going to move the point. There's the point 0, 0, right? Everybody agree? Okay? Now let's do our other function that we just graphed. It was f of x equals x squared divided by x. They look exactly the same. What's the big deal, right? Okay. Let's do the same thing with f of x now. Let's set up the point a f of a. Okay, and let's make that one green, how about?
Green.
Okay, so now I've got both of those points are superimposed. If I drag a along here, look, they both have the value y equals 3 when x is 3. They both have the value negative 5 when x is 5. But what happens at 0?
Green disappears.
The green disappears. How come?
You can't divide by 0.
Doesn't work. Yeah, if I try to do, hey, I got a little too much other conversation going on out there. So if I try to do like f of 4, I get 4. But if I try to do f of 0, it says it's undefined. How come? Because I can't divide by 0, right? So we're going to talk about this eventually. Like in calculus, we would talk about that as a hole in the function. And we'll talk, even in here, we'll talk about that a little bit at the end of the section. We'll talk about where do rational functions have holes, where do they have asymptotes, when we get to the graphing part. Okay? But even though the graphs look identical, there is one point missing from f of x that exists on g of x. And so in calculus, we would literally talk about these two functions. We would say that f of x is a function that agrees with g of x at all but one point. And that's weird that we would even talk about those kinds of things, but that's an important topic in a calculus class. Okay. So the moral of the story then is, it is important for us to exclude those values, right? We have to exclude any values that start off in the denominator. So yeah, this simplifies to just the line y equals x, but we have to exclude that 0 value, right? Okay? Let's do another one. So probably we can, maybe let's go to a harder one. Let's go to well, that's good. We'll do that. That's fine. So what does this factor into, top and bottom? What's the top factor into? What are magic numbers?
7 and 5. No, 7 and 8, not 5.
7 and 8, okay. So we get x plus 8 times x plus 7. What about the bottom? What does that factor into?
X minus 8, x plus 1.
It's plus 8.
X plus 8, x minus 1.
So if I want to simplify this then, and write the function in simplified form, what do we get?
X plus 7 over x minus 1.
Good, the x plus 8's algebraically cancel, right? But whenever we, and this relates to something else we talked about. Do you remember me talking earlier in the year about how, probably many times, when we're solving or simplifying algebraic expressions, we can divide both sides of the equation by a number, right? We're free to do that. But we can't divide both sides by a variable, right? How come? Because we lose solution, right? So when I divide this expression, top and bottom, if I divide both parts of these by x plus 8 to cancel those out,
we should expect that it's gonna change the function a little bit, and it does, right? We lose a point that was originally on the function. Those are kind of related ideas. So our final answer looks like, whoops, looks like x plus 7 over x minus 1. And we have to include the restriction there that x cannot equal 1, but we also have to include the restriction x cannot equal -8, even though those got canceled, right? So in Moodle, the problems you do are going to have two parts. They're going to ask you for what's the simplified expression, maybe not in the first section, but as you get further on in the assignment, they're going to ask you for two parts. They're going to say, what's the answer, the simplified answer, but then what are the values that have to be eliminated from the domain too? So you got to be kind of tracking both of those things. Okay, we could probably skip that, I bet. Okay, so what about if we're multiplying it? Multiplying and dividing fractions, just like it is with numbers, multiplying and dividing fractions is a heck of a lot easier than adding and subtracting fractions. You don't have to worry about common denominators, you don't have to worry about any of that stuff, right? It's just a matter of multiplying straight across or flipping and multiplying if you're dividing by fractions, right? So in this case, if we're just going to multiply straight across, how do you think this changes our process? What do you think? I mean, this is the same thing, isn't it, as they've already factored a little bit, right? They've already factored out. We could have started with, if we were doing this, what if we were doing the same kind of problem we just did where it said simplify a rational expression? Well, whatever answer we get here, we might have just started with that and we factored out an x plus 4 from the top and we factored out an x minus 2, right? They've actually just already done some of the work. My goal is still the same. I want to write this product. I want to write it in factored form, so I've got all the factors on the top and all the factors on the bottom, right? I'm not going to go ahead, I don't want to multiply this thing out yet. I want to get it factored instead. I want it broken apart as far as I can. Then I'll determine what are the values I have to exclude from my domain based on the zeros of the denominator, right? And then we can cancel after that and simplify it, right? So if I multiply this whole thing out, what are the factors on the top?
Oh my goodness. X. Wait, factor or?
Yeah, I mean, these are, factors are just things that are multiplied, right?
Yeah.
So what are the things that are multiplied on the
X
top?
minus 1 and X plus 4.
X minus 1 and x plus 4. Okay, so we get x minus 1, x plus 4. What about the bottom?
X squared plus an X minus.
Well, I've got an x minus 2 already. That one's easy. What about the factors of that guy?
X plus 4.
X plus 3.
And x plus 3, you said? Okay, there's my product, right? So what values need to be excluded? We can just start with that.
Minus 4. Negative 4. Negative 3.
So x cannot equal
Negative 4.
2. X cannot equal -3. And
Negative 4.
x cannot equal -4, right?
Yeah.
Yes. There we go. Okay? Can I simplify this a little bit? Yeah, I've got some common factors there that I could cancel, right? And so my answer ends up looking like x minus 1 over x minus 2 times x plus 3. Okay. Now, I could write that, I could leave it in factor form, or if I wanted to, I could expand the bottom out and write it as a polynomial in standard form divided by a polynomial in standard form. On the assignment, I might have asked you like one time to do that, but I know you can multiply polynomials. I mean, I don't really want you to waste your time expanding all these things out. But understand that if I wanted to write this as a rational function in standard form, that means the top and the bottom I would want to expand out and write them as polynomials in standard form, right? I'm not going to make you do all that work. It takes time. You don't need to, but you get the idea, right? Okay, questions? Okay. What if I have, does that make it a bunch harder? Not really. If you're multiplying, it's, you know, it's the same concept, right? So what are the factors we get on top here? we could maybe do a little bit here even to, like, one thing I could do to make this a little bit simpler is why not multiply negative times negative to make those both positive, right? That makes things a little simpler. Okay, because those are just coefficients, -1 times -1 is +1. So then what are the factors we get on top? I got an x squared, so that's a multiplicity of 2 because it's being squared, right? It's a factor to a power. It counts, technically, it counts as 2 factors, right? Because by the fundamental theorem of algebra. But it only shows up once, okay? How about this one? What does that break down into?
Well, probably quadratic formula.
What's that factor into?
X minus 2x plus 2.
Okay, and then I've got my constant factor of 7 out front, right? We pull the constant out front. That's something we always want to do, pull the constants out front. How about down here? Let's see, I could factor, are there any constants I could factor out?
7.
I can pull a 7 out, and I can pull
4.
a 4 out. Okay, so if I do that, I've got a 4 times 7. What's left behind? Well, there's an x minus 2. What does this become? If I take a 7 out, what's that?
X minus 6.
Okay, and if I pull a 4 out of that one, it just becomes an x squared plus
4x
2x. What does that break down into?
X.
X times
X plus 0.
x plus 2, right? Okay. So, right away, there's no danger in me doing that. I'm free to do that, right? I can cancel numerical factors. That's not changing anything, right? That's okay to do. I don't have to, nothing has to be excluded from any of those factors because they're just numbers. That make sense? It's only the factors that include variables that are gonna have to be careful about. So that one I can just, that makes things a little simpler. What are the values of x that I have to exclude? So x can't equal 2. I'm just gonna do it like this. It can't equal 2, it can't equal 6, it can't equal 0, and it can't equal -2. We've got 4 values that are gonna have to be excluded, right? Okay, any common factors that I can cancel then?
X minus 2x.
Okay, so the x minus 2's can cancel, the x plus 2's can cancel, and what about the x?
Cancel one of them.
I can cancel one of them because this is really an x times an x, isn't it, right? And so I can cancel one of those. Cancel that x, and that becomes a 1. That's the same thing as just our properties of exponents. If I divide like bases, I subtract the exponents, right? So I would, x to the 2 over x to the 1 is x to the 2 minus 1, which is x to the 1, right? Okay, so then what does our final answer look like in simplified form?
X.
Squared over.
I've got an x, the square's gone, I've got an x on the top, and that's it, right? Everything else is gone.
Yep.
What's on the bottom?
4 times X minus 6.
4 times x minus 6, that's it. Okay, so that's our simplified answer, and there's our domain. So when we write domains, we haven't talked a lot about writing domains yet. At the beginning of the year we did. Remember talking about domains, and a lot of times we'd have like all real numbers, or we'd have values greater than 4 and less than 10, based on the graphs that we did. When we write domains like this, if we write domains that just say x cannot equal individual values, what does that imply about all the other values of x? They work. Yeah, those are the only values. It's a lot easier to write it this way, though. The other way I could write this is I could say this. I could say the domain is everything from -infinity, all values less than -2, or all values greater than -2 and less than 0, or all values greater than 0 and less than 2, or all values. See what I'm saying?
Yeah, let's just stick with the other one.
Let's stick to the other way, don't you think?
Yeah.
That's a lot of writing, but that's just as good. We don't want to do that. Okay, same kind of thing. What are we at here? 25. Okay,
Whenever you want, I'll go with that.
let's do a quotient first, just make sure we get one of these. Okay, this, because there's a little trick here, right? So first of all, first thing we have to do is we have to factor everything before we flip. Okay, so this looks like negative x over, what can I factor out there? 2 times divided by, and I really don't like using that divided by symbol. We really probably should write this as a fraction divided by a fraction, but we'll do this way for now. And then this one is already factored. X minus 2 over x plus 4, okay? So before we even flip this, we have to ask ourselves, are there any values of x in either one of these two expressions that we have to exclude, right? So how about this one? -4, and how about that one? -4, so it happens to be the same one in both this time, but it wouldn't always be the same one. So step one, we have to get rid of anything before we flip, right? When we divide, the other way we could write this, of course, would be negative x over 2 times x plus 4, all divided by x minus 2 over x plus 4. And a lot of times I like to just do that. Okay, so now we know that in both of those denominators we have to exclude -4, right? Okay, but we also know that when we divide by a fraction, it's the same as multiplying by the reciprocal. So we could rewrite this as either one of these, as negative x over 2 times x plus 4 times the reciprocal at the bottom. So what's that become? X plus 4 divided by x minus 2. So now, are there any other values of x we might have to exclude? Maybe 2, right? So step 2, x cannot equal 2. Okay, now we can start to simplify stuff and see what remains. But the added part of this is we have to think about all the denominators that show up in the numerator or the denominator of the complex fraction, right? And then also, that numerator is going to end up being an issue too, because when we flip and multiply, whatever's in the numerator of the bottom ends up in the overall denominator, right? So there's some extra values you still have to exclude there, okay? What does factor, or what does cancel? Okay, so our final answer then just looks like negative x over 2 times x minus 2 in factor form, right? You get the idea? We need to do that one or not? Think you got it? You want to just try a couple on your own? Just want to look a little bit? Okay, go.